Welcome back to VTU e-learning Shikshana program on computer aided engineering drawing. We are working on module 2. Today we will work on pentagonal pyramids in different orientations, particularly the axis inclined at 30° THP and 45° TVP or vice versa, or any angle for that matter, and also slant edge is inclined at some degree to HP, or the slant edge itself is on HP. Now let me take a problem. A pentagonal pyramid of base sides 30 mm and axis 60 mm long as a base corner on HP, such that the axis is inclined at 30° THP and 45° to VP. It can be appears to be inclined at some degree to VP, okay, or top view of the axis is inclined at some degree to VP. Let me take first problem on pentagonal pyramid as the regular problem, inclined to HP and inclined to VP, particularly axis. Then we will look into the other parameters. Now let me tell you what exactly the pentagonal pyramid, pentagonal prism, whenever you go through some question papers or the questions asked by your teachers, normally pentagon shape will be there. It is something like share, tiger type. Why I say this? Because of the mistakes we commit in preparing the initial position or preparing the pentagon itself. Now I will tell you how to prepare the pentagon. Now if I take a general information, pentagon is actually having one side with two more sides adjacent to that with 108 degrees interior angle, and all sides are equal, you know, and these two sides are again equal. That means you have to maintain 108 degrees while working manually and keep this. Now how to prepare this? Basically, first draw a line, then 108 degrees, 108 degrees, normally we commit mistake by taking 112 instead of 108, that is one mistake we commit. Then take these two as centers, draw arcs, then the same centers, these 2 points, and then same radius you draw. So that gets you this, fine. Now this is actually corner condition I am keeping, okay, let us think that type of orientations afterward. Now let me concentrate on the basics. Now start from naming A, B, C, D, E. Now this is top view of the base of the pyramid. Now if I take pyramid, pentagonal pyramid, you have base edge perpendicular to VP. A simple position I am showing. These are the base edges and these are slant edges for a particular height. Now if you look from top, you will get the top view as pentagon, even though base is not visible, boundary is visible, edges of the base and slant face edges are common. So that is why this is visible. Say. Next, what about top view of the slant edges? If you have to identify the center, that means you have to draw two perpendicular bisectors, preferably one horizontal and any other one. Even in computer you have to do this, okay, it never gives automatically, it gives automatically pentagon, not the center, okay, center you can identify, but you have to draw all these. Now how to complete the top view? Top view can be completed by using the dark line if necessary in that particular event. So dark line, then draw all slant edges. This is vertex and this is O. I always use VO, vertex V and O. Why you should not use OO1? You can use, but there will be a problem, confusion will be there, and do we end up with trouble afterwards at the end of the session, I mean completing the problem. Now this is V, this is O. So O is not visible and O, V is towards observer. Next, join all these corners. This is what we forget normally, okay, this is must. then fix the views, front view, top view according to the requirement. This is how you have to draw. Now, in this position how to draw the front view? Project all these points and project this also and fix the height 60 mm. Join the apex with all base corners. See, this is A, B in sequence I am getting. This is the advantage of keeping the left extreme corner as A, B, C, D. Next, this is E, then this is D. Join all these points with apex. Yes. Now, what exactly you have to do with this? What all to be marked? Dark line. Yes. As usual, we mark VA, VB, VC. Fine. Now, what about this? This also we forget sometimes. So, dark this base surface. Next comes the axis. Axis must be identified with the convention full line hyphen full line hyphen. So, this is how you complete the projection of a pentagon. Now, you see this also should be dark. So, I repeat, base edges must be dark, the slant edges must be dark. Normally we miss this and keep only OV and these two lines medians. Then O dash V dash. So, let me review. A, B, C, D are the base corners, V, O, V represents the apex and O represents the top, bottom end of the apexes, and this is the projection. So, I am insisting on this. Normally the mistakes will be in this pentagonal shapes, particularly pyramids. Now, if I take up this pentagonal pyramid for this particular problem, he says edge condition, that is the edge on HP, base edge on HP, sorry, base corner on HP, base corner on HP. So, this is base corner I am taking to the right side, preferably to the right side you take, particularly for solids. For laminae we take to the left side. Now, let me take the model and then explain this particular problem. First position, second position. So, why not this first position? As I explained earlier, in laminae as well as solids, this becomes edge condition. So, corner, again there is one more class there, condition. The corner must be placed in such a way that the perpendicular bisector passing through that point or corner must be parallel to VP. Then only once you incline this, the axis will be inclined to only HP, and these two base sides containing the corner and HP make equal inclination with HP as well as VP in this condition. But once you give inclination to VP, the inclination to VP changes, but these two will have same inclination with HP, equal inclination with HP. That is the basic condition. First position, second position. So, initial position is the axis inclined to HP. So, you make it perpendicular to HP to get true shape on HP, fine, you are getting the top view as true shape. Now, dimensioning and all is common, you must do it accordingly. So, whatever the dimensions given, must keep it 30, and here with the specified thickness you have to keep 60. So, this becomes initial condition for the particular problem, first position. What about second position? Let me take this particular problem first. 30 degree to HP, inclination to HP only you consider and then do it. First position, second position. Here in case of prisms, already pyramids, I already told you, you cannot take the slant face or slant edge directly for this axis inclination, you take the base inclination. So, axis inclination plus base inclination equal to 90 degree. So, here the axis inclination is 30 degree. So, that actually base inclination will be 60. So, in computer what you do is you move and rotate this figure such that CA as reference you move by 60. So, that you will get axis inclination 30. In this case also manually you have to draw like this. First position is this C dash, you mark C dash, then draw a line inclined at 60 degree. Okay. So, because 30 degree is the reference, take 60 degree and mark these points. So, take with compass same distances, you must mark here. Suppose that if you take in this sequence, you must mark in this. If you do ulta, then problem starts. You never get the solution. Now, after getting shifted this here with the compass, then draw perpendicular line through O. This is O dash, this is B dash, D dash, this is A dash, E dash. Fine. Now, draw perpendicular. So, after you draw perpendicular, you are going to fix the axis at the given height. Okay. Say this is V dash, this is O dash. Join them. So, this is how you get 60. Then you measure, you will get 30 degree as required. So, let me complete first with the light line, or directly you can complete with the dark line only, no problem. But if there is any confusion, you can keep first whatever is available, you must keep it here. Check twice whether order is maintained. CBD, yes, then O, then comes AE. So, then only this becomes perfect. Then this is 60, definitely this gets you 30 degree. So, after you clarify this condition, then go ahead with the second figure top view. How to draw the second figure top view? So, first you keep the base only, do not draw all these projections up to V, draw only this topper, say using alignment indicator into computer, whatever the points you want, only that one you fix. Otherwise, manually also you can optimize your work by projecting only this, but do not project axis. This is most dangerous line. I will tell you why. Then V. Mark these points. This is A, this one is B, this is C, this one is D, this is E. Draw this lines joining all corners. Next, mark V. V. I have not marked projected up to this. This is only one line sufficient. Then keep this. All are light lines now. After this, you can see that the visibility concept, what are the lines visible, dark, dotted, etc. Suppose that you draw axis line only, axis line also first. Instead of D here, you will be marking here. Instead of B here, you will be marking here. And ulta, this one here and one more here. So, all these things will be there. I will show it on the computer how exactly possibilities are there easily. Already I have shown you, still I can show with this problem also. Now, at the end you can mark axis and mark. Now, which method you follow, key surface method or farthest point method or item method? I will tell you, I will give one clue for you, very easy. If you look at farthest point item, it is corner. All corners joining that invisible corner or item are within the boundary, then easily you can adopt farthest point method. Otherwise, if there is any confusion, number of lines are there, it is not clear, then you can go for key surface method. Key surface method works for all problems, but here it leads to confusion at the second stage. Here you can easily work. I prefer to work with farthest point method here. Now, C is the farthest point for you. Base corner C is the farthest point from you. Here you are here. that is not visible, number 1. Any number of lines joining this particular point are not visible. So, C is not visible and these 3 lines joining this particular item which is not visible or farthest item from U are not visible, that is all. Rest of the lines are edges are all are dark. Now, dark all edges, always boundary lines are dark, that you know. Now, irrespective of the positions, you can dark all other lines except these 3 in one go. Yes, this completes the solution. Okay. Now, I will repeat, if you look from this direction to complete the second figure top view, C is the farthest item from U, that is not visible, and any number of edges either slant edge or base edge connecting to that are not visible. So, hidden lines. Rest of the lines all are dark, and see that all boundary lines are dark, that is always there. Okay. Next, we have completed all edges, visible, invisible. Then what about axis? But there is little scope for axis representation here. Already hidden line is occupied this portion, and O to C you can mark, that is only representation by the full line hyphen full line hyphen. Okay, you can use 0.25, 0.35 in computer, and what best you can do is you can zoom that area and then remove whatever line available, then replace that or modify that. Suppose that if the continuity line is there, then you have to go for split, otherwise you use trim, then you keep these 2 out, then you can replace that with the axis. So, this is how we can complete the top view, second figure top view of the problem. Next comes the axis, again is inclined at 45 degree to VP. So, what best you do is you realize that OV of second figure top view is its true length. No, because already it is inclined to HP, it is already become apparent length. So, you are supposed to keep this is apparent length, you will get some value. True length is 60, apparent length will be less than that definitely. Now, you are supposed to find beta. Why you have to find beta? OV is apparent length, AL on AI, apparent length on apparent inclination, that is beta. So, find beta. So, this is how you can analyze the given problem, whether to find beta or not. Now, after completing this figure, now how to find beta? You can do it separately or here only, but here if once you are start rotating, then there will be some confusion or the angle shifting and all will be there. I will show you on computer how exactly you get problem. Now, basically you are supposed to work for finding beta. I will show you how to find beta. This is V. Always I prefer to take the base towards observer. Then 45 degree is the line, draw 45 degree line, take true length of the line, okay, true length of the line you take. Then this is V, this is O of true length, OV of true length, this one. Next you take apparent length, mark, then this is O of apparent length, apparent length will be marked, then gets you the. So, on this line, beta degree line, you have to find the, you have to place this VO of second figure top view, that is all. This is phi, this one is beta. So, you have to replace this. So, now let me, since it is simple geometry, I can always draw this figure. You have to redraw this figure. How to redraw this in computer? Select this, move command, particularly V you move up to this, then you rotate about V only till it this VO coincides with this point, okay, O of apparent length, then you will get the final solution. Suppose that if they give appears to be inclined at 45 degree to VP, directly you take beta equal to 45 degree and draw the figure. Or top view of the axis is inclined at 45 degree to XY, if they say top view, they will address to XY, not VP, okay, then also beta is given, okay. This is how we can complete the problem. Now, let me draw and then show you how exactly you will get the solution. Now, assume that I am working manually with the computer, you know, move and rotate. Here what exactly we do is, let us keep this O as reference and mark these points better. Let me, for geometry replacing purpose, redrawing purpose, we will keep it N and M. Now mark this here N, M and C, that is all. Then through that you draw perpendicular lines using small protractor or any set squares. Then you are supposed to take this is C, directly you get. You are supposed to take only two distances and mark all the points. See, let me take MD equal to MB, you mark from this O, okay, not mark from M. So MD, MB, then you take this EN equal to NA, that is all. So you will be getting these points. Now draw light lines, say, okay. Now join these points. Okay. Assume that I have redrawn the same figure and dark the same. Whatever is available here, let me draw. Okay. Now name these points as available in the second figure top view, C, D, this is E, sorry, this is E, this is A, this one is B, already C is there. Now dark all this, okay. Now let me check VA, VB, VC, VD, VE, all are available. Whatever is available, I have redrawn this figure such that VO is on beta degree line. So this is basically 30 degree, okay. Now again you have 45 degree inclination, then you will get beta equal to 55 degree if you measure, that is what we used to get, okay. So now you project it up, project the same towards the front view and get the all points ready. Now let me mark C on exactly on XY line because it is on ground, C dash. Next point is BD, BD, this is B dash, this is D dash. Then AE, unnecessary lines you can avoid by keeping this is E dash, this is A dash. Every time you check twice whether you have made it properly. Now V finally, before that let me join this to avoid any confusion, okay. You may get the variations D this side, E this side, or because of angle changes. Here I have taken approximate angle and drawing. Now V, mark V, okay. Now so join all corners of the pentagonal base with apex. This is again refers to the key surface reference or the farthest straight line. Let me take farthest point only and check. See, V is the farthest point from you, V is not visible, fine. Normally we say all edges which are joining V are not visible, then there will be always confusion. Say okay, E dash V dash and B dash V dash is not visible. No, boundary lines always visible. So now we confirm that E dash V dash and E dash B dash are visible. What about V dash A dash and V dash D dash and V dash C dash? All confusion we get. So for that, what best we can do is, or somebody may say if you look from this direction VB is visible, VA is visible because they are nearer to the observer. That and all we can clear by key surface method. So which key surface is visible? Key surface, see first position, yes, first position, second position. I have taken base towards observer. Base is, I have made it yellow purposefully, dark color. First position, in first position base is not visible. See, I will tilt by 90 degree. Base is not visible. Assume that is top view for you. Next, next case also base is not visible, that color is not visible to you. Now what I do is, after first position, second position, I am keeping like this. See, base is towards observer. Suppose that if I keep it like this, again base is not visible, base is away from the observer. Now that case also I will show you on computer how it looks like. First position, second position, third position. Now base is visible. So key surface, there are two key surfaces in prism. In pyramid we have only one key surface, that is visible now. So procedure is very simple and easily you can understand. Draw all edges of the visible key surface, that is basic procedure 1. Draw all visible key surface, that is the only criteria you need to complete the show. It is very easy. We do not need any other orientations. Which is the nearest key surface? Whether key surface is there or not, that also we will take. Key surface is there, definitely its base is visible, dark. Now all boundary lines are dark. Yes, all boundary lines are dark. Next, invisible key surface is not visible. So no invisible key surface because we have pyramid, apex, then drop that procedure step. Then go to the two easily understandable item is visible bends, invisible bends, or visible surface, invisible line, invisible surface, visible line. This is fundamental concept, basic concept. See, this is invisible, visible surface, any number of edges crossing that are not visible. See, for example, in this case there are number of edges here, black red, dark red color, this is yellow. Now you can see only yellow surface, not the edges which are back side, okay, just behind this, okay. So visible surface, invisible line. So here invisible surface, visible line. Suppose this surface is not visible, these edges are visible, slant edges, okay. So that is how you can complete. Now visible surface, invisible lines, okay. So one more line left, that is AV. AV, what is about AV, whether it is visible or not? It is visible because of this bends, because the surface is visible, definitely A dash, V dash is visible, okay, or otherwise one can say this is very near to the observer, that and all is, you must have imagination, otherwise it is difficult. This is best, visible bends, invisible bends. This is A dash, B dash is visible because of bends, this two are visible, any line, number of lines joining, normally 3 lines joining a point in this type of problems, definitely these two are visible, this is also visible, that is enough, okay. Now this is how you complete the solution. Now add the axis also here, it is very important for all solids, keep axis represents, okay. Suppose that they ask axis appears to be inclined at 30 degree to EP or etc. again 45 degree to EP, then you take directly beta equal to that I told you already. Now there are two more cases, slant edge containing the corner HP is inclined at 50 degree to HP. What you do is, this becomes, this is your slant edge, okay, slant edge, and this will be placed on ground if you rotate with the axis reference. Assume that this is the reference for you, okay. Now you can directly rotate. In computer what you do is, you can directly take this figure, move, and then about this point you can rotate, but how much you rotate, you have to calculate all this. For that what you do is, draw a line initially 50 degree or whatever given, I have given 50 degree, okay, then rotate and see that this line is on that particular 50 degree line, that is all. Then do not worry about the axis. Here axis I had mentioned, in that slant axis, slant edge method, you mark this is 50 degree. So again this type of problems you can solve, rest of the procedure is same, Okay, then they may say axis inclined at some degree to HP. Yes, you see that axis already inclined to HP. Once slanted is inclined to HP, X also assumes some inclination. Anyway, it is inclined to HP. It assumes apparent inclination. Then take again beta. Not necessary that slant edge only should be given for the apparent angle. Slant edge only can be given. This is inclined at 50 degree and some degree to VP. Then the slant edge also has been reduced, that is apparent length. With this apparent length and this true length, you find beta. Normally they refer to axis, or they give appears to be inclined at, or top view of the axis inclined at some degree to be, you take accordingly. Then finally slant edge on HP. So instead of some inclination, what they do is they give question like this. They slant edge, you rotate this particular figure in second figure front view such that C dash V dash is coinciding with, this is C dash, this is V dash, is coinciding with XY line, that is on HP. So again the same type of question can be asked. Instead of inclination to VP with the axis, they may give the slant edge itself on HP is on HP and inclined only to VP. Then apparent length, apparent angle will not be there. True length on true inclination. This type of problems we will discuss on computer. Let me take a simple problem on pentagonal pyramid, which will be the initial condition for the problems which are coming in future. Now, let me take a pentagonal pyramid, has its base on HP such that the base side is perpendicular to VP, or a perpendicular bisector is parallel to VP. Perpendicular bisector of the base is parallel to VP. Here I have not given any dimension. Let us assume 30 mm base sides and 60 mm height. So normally whenever you get a problem on pentagonal pyramid, we draw for corner condition, because corner to be taken to the right side and the opposite side must be perpendicular to VP. It is similar to the laminae which we have discussed, and also pentagonal prism we discussed already. Now we draw this figure and we complete, but which one to be marked dark line? Okay, as usual base edges are to be marked dark. Yes, we have drawn dark, and the front view we have made these lines dark. Now what about this? This is also very important line which is considering base, consisting of base. If you look from front, it is dark line. Yes, you have to dark it like this. This must be the complete figure. Now in this case also, normally some of the answers I have seen, they leave as such this type only, but here they are not completed the slant edges. See, VA, VB, VC, VD, VA, all are slant edges that must be marked with dark line, 0.5 in computer drawing. Now here these are the dark lines to be maintained for a simple problem like this. This becomes initial condition for next coming problems. Now let me take a problem and discuss. Here a pentagonal pyramid of base sides 30 mm and axis 60 mm long as a base corner on HP, such that the axis is inclined at 30 degree to HP and 45 degree to VP. Draw the projections. In this case, if you look at this data, it's a straight line problem. Axis inclined, the line is inclined at 30 degree to HP and 45 degree to VP. The final inclinations of the line, or in this case axis, will be on alpha and beta. So naturally you have to find beta here. Okay, then we will look into that at the final stage. Now what about the initial condition? Initial condition is axis is perpendicular to HP. Now we have made it because to get the true shape on HP. Okay, so if axis inclined to HP, you make it perpendicular to HP so that you get the true shape of the base of the pyramid on HP. Yes, pentagon. Now you know how to draw the top view, front view. Now how to continue this? So you have to give inclination to the HP, VP, HP with respect to the axis. Now we have to move and rotate. How to move and rotate, I will show you there only. So take this move command and see that this heading item will be there, because it will disappear afterwards if you don't consider. Now you move like this with reference to C only, because it must be on ground further. Okay. Now, how to rotate? What about the axis inclination? 30 degree. So, you convert always axis inclination into base inclination. Axis inclination plus base inclination equal to 90 degree. So, 90 minus of 30 gives you 60 for the axis. Now, rotate the figure with respect to the base reference 60 degree. So, this one rotate yes is 60 yes. Now see that this is blank yes. Now check for the inclination of the axis, whatever we want is to be available. See, this is 30 degree. So this is how you can move and rotate in computer. It's easy. We have done this job in laminae as well as solids of different shapes, basic shapes. Now this is what we move. Next you rotate by 60 for the base, then you get 30. Here I have given the simple calculation, axis inclination plus base inclination to 90. We want base inclination, 90 minus of this, definitely you get 60. Accordingly you do it. Next comes the projections. Unnecessary lines you can avoid. I have taken specific points. Okay, suppose that if you take B, that work for E also. Okay, if you take for A, if you take for A, that works for E, and if you take for B, then again it works for D. Unnecessarily projection should not be done. Here it's only a single point, X. Next comes join all these points. Fine. Now, if you look from this direction, okay, which is the farthest item from you? I prefer to have farthest item reference here to complete the view, second figure top view, because see, C is not visible according to this is C, base corner C is not farthest item. A number of edges joining that, see, one slanted and two base edges are joining this, they are well within the boundary. Okay, no other lines references. So definitely if only these three are there and this is within the boundary, definitely you can use farthest item method, but it's very easy to complete. Now CD, CB, CB are dotted and rest of the lines are dark. That's what here. See, suppose that I told you already, if you project, here I have not projected the axis O. If you project axis, then there will be possibility of committing mistake. Instead of this particular D, we mark here. So in hurry, and also if you don't have basic concept, then you do this job. So that's why I avoid, don't give scope for this, don't project this at the beginning. Now the correct thing is this, okay, after that you project. Okay, here also there is a problem. Now I have given two situations where you commit mistakes. Here both you mark there, and here you mark one on the regular one and other one on the axis. Then this one is correct as we did earlier. Now you project the O also, that is axis reference. Now the points which are not visible is farthest item is currently C, then C is not visible. These are the three lines which are not visible. So I have identified here. Farthest item from the observer is C. Edges CB, 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 DCB, CD are all not visible. Then rest of the items are edges are visible. Either slant edge or base edges. That's what I mean. Boundary lines as usual it's visible. Next comes, there is a little scope for axis representation. Here I have not done. See here what I have done. I have taken this trim and I did this job here. Now you replace that with this. Now what exactly given? The axis inclined to HP as well as VP. So you have to find beta. That procedure you know. So far we have worked out number of problems, but since it has reduced to 51.96 instead of 60, apparent length, because of this inclination, the apparent length you have to find. So after that you rotate and see that the VO is on beta degree line. Yes, it's there. Now project it and get the front view. Only thin lines. Now, after getting thin lines, you look from this direction, farthest item from you is V. So V is there. There is a lot of confusion. So boundary lines okay, dark, even though it is joining. But what about these three lines, VA, VD, V? Again, you have to approach, and also then confusion is there. So what best to do is, you take the key surface reference. Which is the visible key surface? Nearest key surface to you. Okay, this is base. That is the only criteria you need. Rest of the things, the sequence of procedure will take care. Now, dark all these lines. Okay, base edges. First, basic procedure 1 is dark all base edges because it is nearer to the observer. Yes, I have taken this colored one is the first procedure. Next procedure is take the boundary lines dark. Completely these boundary lines dark. Okay. Now, visible key surface is base, then dark all base edges. All boundary lines are dark. Yes. Then what about invisible key surface? We don't have invisible key surface because it is pyramid. Next comes the procedure either visible surface, invisible line or bends. Here I have this say, I have utilized bends reference. A dash B dash is visible because of this. Or somebody may say, because AB is nearer to the observer, that is also visible. Somebody may say, why not VB, etc. So that confusion can avoid by keeping this key surface reference, bends, visible bends. This line is visible, this line is also visible. Okay. Next comes these two lines, that is VD and VC. It's definitely crossing lines or visible surface, invisible line. So I have shown you this. See, this colored one is visible. Inside that colored one, edges, two slant edges are moving. Definitely the entire length is not visible. Somebody may say only this portion is visible, is not visible, then this portion. No, the entire line is not, because it is backside of the solid. So okay, now after completing this, then axis reference you have to complete. Then this completes the problem on the pentagonal pyramid with base corner on HP and axis inclined at 30 degree to HP, and the axis also inclined at 45 degree to VP. Then you get beta, then this is the solution. So this is the final solution when base is near to the observer. Suppose somebody may ask, the base is away from the observer, what you will get? Definitely you have to redraw like this. Move and rotate such that base is towards the VP, then it is away from the observer. So key surface, none of the key surface is visible because only one key surface is there, apex is towards you, definitely it is visible. You cannot do anything with that because surface is not there. Now, if you complete the figure, you will get, let me get all the thin lines first. Then, since base is away from the observer, base is not visible. Okay. Boundary lines completely dark. First procedure, you skip the first procedure, visible key surface dark because we don't have visible key surface. Second procedure is all boundary lines are visible. So now what I have done, all visible lines are dark. Otherwise here also you can do same thing. Suppose you check for the farthest point from you, base is towards observer, it is easy, farthest point you can do instead of visible key surface. See, here what best you can do is, you check for the farthest point from you is here. Farthest point from you is here, E. Okay, E is the farthest point from you. Fine. E is not visible. And whatever the number of lines connecting to that are well within the boundary, then you can utilize the farthest point method. Suppose there is no confusion here. Okay, even you can use key surface method because base is not visible, boundary lines dark, then individual key surface edges are dotted, then these two are dark. So here I utilize the farthest point from the observer only. It's easy because of this situation, because all lines which are joining invisible item are well within the boundary. So dark dotted lines for all the invisible key lines which are joining the farthest point, that is E. Okay. Now all other lines are visible. This is easiest way. Yes. Otherwise, in key surface method also we can do. See here, visible key surface method, we don't have visible key surface. We go for boundary lines dark. Then invisible key surface lines other than boundary lines are dotted. Then this is invisible bends. This is crossing line. There is no visible bends here. Okay. So definitely you can complete with this reference. Easy. Now let me take up the alternate solution, final this one. Okay, this is the surface, the base is away from you. Definitely this becomes the final solution. Okay. So here also we have to have the clarity with the visibility. Okay. Now let me go ahead with the next problem, generator or the slant edge. In case of cone it is generator, in case of pyramids it is slant edge. Okay. A pentagonal pyramid of base sides 30 mm base edges and axis 60 as a base corner on HP such that the slant edge containing the corner on HP is inclined at 50 degree to HP and the axis is inclined at 45 degree to HP. Draw the projections. They give suitably. They never give 20 degree or something like that. Why I have given 50 degree I will tell you afterwards. Now let me consider this. You move and rotate. How to redraw the second figure front view? Okay, like this I will show you. I have to do like this first. This figure how to draw? First what you have to do is you move the figure, first figure front view. From C you draw a line, 50 degree line. Then you rotate this figure so that CV is coinciding with this line. Otherwise what you have to do is you have to take it, find the total angle of this and then subtract this, then rotate about that, about this line. For that it may be fraction sometimes. Don't take that risk. Draw this line first, then rotate. Then you get the inclined figure with respect to CV. CV is the slant edge which is inclined at 30 degree, 50 degree to HP in second figure front view. So V dash C dash is the line is on a line inclined at 50 degree to XY. Okay, you have to refer XY only. Yes. Okay. Now after getting this, you project and complete the figure. So here you look from this direction. And the farthest item from you is C, base corner C. C is not visible and number of lines connecting to that are well within the boundary. Definitely you can use this farthest item method and then complete. See, these three lines are invisible, rest of the lines are visible. Again here you take care of the axis line, initially don't draw so that you can complete the figure correct and then continue. Now as you observed there, the axis is inclined at some degree to BP. Now I have not given axis inclination, I have given this slanted. Still the axis inclined at some degree to be given. We have to find out beta because even the slant edge is inclined. This also assumes the corresponding angle that depends on the height of the solid. Okay. Now here it is 53.36. There I have 51.96. Here it is 53.96. For that you find instead of 55, I got 53 here. So definitely it works when you realize what exactly you have to do in the future steps. Here it is apparent length. Definitely you must keep it on apparent inclination. Say I have given the axis inclined 45 degree dB. In second figure top view OV is apparent length, AL on A, apparent length on apparent length, that is beta. Find beta. So OV is on a line inclined at 53 degree. So you separately you find it and then keep directly on 53 and show somewhere. Okay. So you have to have space management. Otherwise you do this here only and move and rotate. You have to take this V as reference, move up to this, then rotate. Okay. That's what I have done here. Okay. So This is how you move and rotate with respect to, see, OV must be on beta degree line, 53 degree line. Okay. Now, finally, you will get this. Here, as I told you earlier, the farthest point item method is not suitable because there is lot of confusion. Okay, one basic nativity you can do as we did earlier. Here again, the key surface method is best. Visible key surface is base, so base is visible. Yes, and then boundary lines are dark. These are crossing lines or visible surface, invisible lines. See, visible surface, key surface, base is dark. Then boundary line is completely dark. Then this is visible bends. This is crossing lines or visible surface, invisible lines. Okay, you can use this for validation. Suppose that you do in one method and check that all crossing lines are opposite in nature, and two lines are already dark, one more line joining that particular corner also dark, that is bends, or this is invisible bends. You see, these two are not visible, this is also not visible, this is invisible bends. Like that you can validate and also clarify the doubts. Now, this is the final solution with all axis representation and all, okay, for the slant edge is inclined 50 degree to HP. Next comes the generator, slant edge on HP. Before that, let me take, see, I have used O01, no doubt, 90%, 95% of the people do it well without any mistakes. But some cases in hurry, we project this O on this O dash also. O1, O we get confused and then project here. Instead of, this is the point of your of our interest. This is no man's land. You cannot project here because this is O. You are assuming that this is also O, locus of O, you project here and get wrong answer. So this should be avoided. That's why we always prefer to have VO. We never project. Okay, you forget this in fact. Now, next item is slant edge on HP. Okay, let us take one problem. See, the pentagonal pyramid of base sides as a slant edge on HP. The top view of the axis is inclined at 45 degrees. This is as good as giving beta. The axis appears to be inclined at some degree. It's also the top view of the axis inclined at some degree to XY. Now, the same thing I have given, other version appears to be inclined at. So, what you do is same initial position, because slant edge always refers to the corner condition. Slant face means it is the edge condition. I will show you that also. Now, the corner condition you draw, you know how to draw the top and front views. Then you completely rest this figure such that C dash V dash on XY line, that is on HP. Whatever you do here, that is for HP. C dash V dash is on XY line means actual C V, the slant edge on HP. Now, you project it and get the top view. Now, as I told you earlier, again visible key surface method is best for this, because the farthest item from the observer is CV. But once CV is not visible, all these lines joining are not visible. Some people get confusion. So for this, definitely key surface method works well. No mistakes will be done. Now this base is facing the observer, not the true shape, very close surface, that is apparent shape you get, is visible. So dark all the visible key surface. Then dark all boundary lines. See, dark all boundary lines. Visible key surface are dark, boundary lines are dark. Then invisible key surface edges other than boundary line dotted, but there is no other key surface. Forget that particular step, you avoid. Then there are two things. One is crossing line or bends. Here or visible surface, invisible line. Say there is only one line crossing the visible surface, that is CV, that is not visible. But it is also fact that CV is away from you, that is not visible. It is the only line which is not visible in this case. And AV and EV are visible because the this line EA and BA are dark. This is also dark, bends. Again, this also bends. Okay. Now you can complete that. This is invisible crossing line or visible surface invisible line. This is bends. See. So this is how you can complete the solution. That is step 2, top view of second figure. Now what he says, the top view of the axis is inclined 45 degree to XY. The top view of the axis means OV. Normally they give axis inclined some degree to VP or appears to be inclined some degree to. Appears to be means beta is given, and directly if they give, they say it is inclined. But here top view of the axis is given, definitely you must take the top view as OV definitely. Then this gets you the inclination 45 degree beta is given. Then you have the top view. Again here you can take the key surface method. Then boundary lines dark, visible key surface dark, boundary lines dark. Then the visible bends. See, BV is visible because CB and AV are visible. Then the crossing line, red color I have used for crossing lines. Okay, visible surface, invisible line. Okay. Now finally you mark the axis also. That completes this problem. Now we have worked out 3 problems with variation with visible key surface method and the farthest method. Which is best method you can decide now and use. Ultimately you can combine both, check the figure with both the methods. Okay, so that is best. You can mix the method for second figure top view. Wherever the edges are within the boundary, you can use the farthest point method. If there is any confusion, you always use key surface method. Okay, then we will take up the next problems in the further sessions.